Okay, we'll continue our this article for homogeneous function. Now interested thing is here. I am taking now u is homogeneous function of degree n. For this homogeneous function, I will tell one story about this homogeneous function such that this homogeneous function is of degree n, and we are knowing that if function is homogeneous in x and y of degree n, then we can write this function as x raised to n into phi of y divided by x raised to power n into phi of y divided by x. I will differentiate this function partially with respect to x because this is function of x and y. I will find its derivative with respect to x. Now here, while finding derivative with respect to x raised to n and this phi function, both two functions are here. We have to use product rule to find out its derivative. I will find derivative of x raised to n into x raised to n minus 1, keeping second function as it is constant, plus x raised to power n into derivative of this function is phi dash of y divided by x into derivative of angle. We are finding derivative with respect to x. This is y divided by x, and derivative of angle is minus y divided by x square. Y I am keeping as it is, and derivative of 1 by x is minus 1 divided by x square. After this, I will multiply this whole equation by x into w by x, which is equal to n into x raised to power n phi of y divided by x plus I am multiplying this term by x. Here this is x raised to power n and this is x square. This total becomes x raised to power n minus 2. This y term is already here, minus inside, and for this total term we are multiplying by x. Therefore this total term becomes, I will write here this sign, I will write here minus y because minus y is here, minus y into x raised to power, this is here n and here is x square, this becomes here n minus 2, and we are multiplying by x, then total becomes n minus 1 into phi dash of y by x. This term I am multiplying by x and we are getting this term, and I am giving this is equation number 1. In similar way, I will differentiate this function u with respect to y. W by y is equal to x raised to power n phi dash of y divided by x into, we have to find derivative of angle with respect to y only, therefore this is 1 by x. This again total term I will write x raised to power n minus 1 into phi dash of y divided by x, and I will multiply this term by y into w by y is equal to y into x raised to power n minus 1 phi dash of y by x. Means what I did, given function u is homogeneous in x and y of degree n, I am finding its partial derivative with respect to x and multiplying by x, giving as equation number 1. I am finding partial derivative with respect to y, and then we are multiplying by y, giving equation number 2. If I will add these two equations, adding 1 and 2, we get x into w by x plus y into w by y. This is your RHS. This RHS gives from this LHS, adding 1 and 2, LHS of 1 and 2, then we are getting RHS as here. This is your minus y into x raised to power n minus 1, and this is your y into x raised to power n minus 1 into phi dash of. This term get cancelled and remaining term is here n into x raised to power, we are getting here x raised to power n into phi of y by x. And again we are doing that this term x raised to power n into phi of y by x, this term is our u, given u, therefore I will write this is equal to u. From this we are getting x into w by x plus y into w by y is equal to an u. Now this is again very important relation, and this relation we are getting because of given function u is homogeneous. And here moral of this story is that if u is homogeneous function in x and y of degree n, then this follows: x into w by x plus y into w by y is equal to nu. I will try to write this moral here. If u is a homogeneous function in x and y of degree n, then x into w by x plus y into w by y is equal to nu. In similar way, I will generalize this. If u is homogeneous function in x, y, z of degree n, then we can write x into w by x plus y into w by y plus z into w by z is equal to nu. And this formula is stated by great mathematician Euler. This is called Euler's theorem. What is Euler's theorem? If u is homogeneous in x and y of degree n, then x into w by x plus y into w by y is equal to nu. Or if this is in 3 variable, then we can write this function in this way. For higher or second order derivative, we can write this, and I will directly write, we can generalize this result as x square into w by x2 plus 2xy w by x y plus y square into w by y2 is equal to n into n minus 1 into u. N into n minus 1 into u. Means for higher order, this formula becomes in this way. Here this term is n into n minus 1 into u for higher order. Means second order. Euler's theorem, I will write statement of this Euler's theorem in first and second order form is u is homogeneous function in x and y of degree n, then x into w by x plus y into w by y is equal to nu. And second order is x square into w by x2 plus 2xy w by x y is equal to plus y square into w by y2 is equal to n into n minus 1 into u. This is our Euler's theorem, and this is very useful from the point of our exam. And again, for third case, means if u is homogeneous in x, y, z, then we can write this case as x into w by x plus y into w by y plus z into w by double z is equal to nu. Okay, thank you for this lecture, and we'll take examples based on this Euler's theorem in coming lecture. Thank you.